Assalamualaikum warahmatullahi wabarakatuh. Now we learn about the system of linear equation. The system of linear equation have the definition as linear equation is an equation involving one or more variables in which the operation of multiplication by a real number and some of the term are lowered. For example, if you have a 6x minus 3y, you have 6x minus 3y. It is the linear equation equal to 4, for example, it is the linear equation. But when several linear equations involving the same variables are considered together, we have a system of linear equation. So if you have some linear equation like this one, but the several number of linear equations involving the same variable, so you become the system of linear equation. How if we have a linear equation system to solve by using the matrix? An alternative way to express the system of linear equation is to form the augmented matrix. It is the form of augmented matrix, the example of the augmented matrix. So if you have this one, we can input the number to the augmented matrix, also the b equal to the result of the solution. Then one of the most familiar technique that is used to solve the system of linear equation using the matrix is a Gauss elimination. In Gaussian elimination, we have the term of this one is the algorithm located the pivot positions and then make the certain entries of the matrix 0 by mean of elementary row of operation. We have 3 basic operations. We call it as a type 1, type 2, and type 3. Type 1 by multiplying a row by a non-zero scalar. And the second one is adding a scalar multiple of one row to another row. And the third one is switching the positions of 2 rows in the matrix. So to help us more understand about this, so I give you the exercise, and by using this exercise, we can understand how to make the augmented matrix and to solve by using the Gaussian elimination. By using the augmented matrix, so the first step, we have to change this system of linear equation to get the augmented matrix. So we can write this one: 5 minus 15, 4 minus 2 minus 6, and 3 minus 6, and it is minus 17, and this one is revert to x, is revert to the y, and it's the z. So what is the augmented matrix? When we add this one by the solution set, then we can write this one is 40, 90, and 41. So this is the augmented matrix. After we have the augmented matrix, then we continue to the 3 type operation. We use the 3 type operation application of the Gaussian elimination. Now we can perform row operation on this matrix. So we can perform the operation on this matrix to give it the simple form, proceeding the column from the left to the right. So it is from the left to the right, from the up to the bottom. Starting with the first column, we choose 1.1. We use entry 1.1. So it's mean here it is. But we take the 1.1 entries, which is the number is 5. Position is our. We call it as a pivot entry. And then we have to place a number 1 here. We have to place a number 1 here. So how we can take the number 1 here? Of course, we can multiply the pivot row by the reciprocal of the pivot entry. So we can multiply it by 1/5 or etc. And then after that, we can because the row containing to the current pivot is over-delivered as a pivot row, so we can say that it's a pivot row. Then the number 1 is this row. It becomes the pivot row. Now placing 1 in the matrix of the pivot row here, and then we generally use type 1. Use type 1. Okay, we start. Use type 1. How we use the type 1? By multiplying the reciprocal of the number of pivot M3. So type 1 operation is for the row 1, we can multiply it, the row 1, by 1/5. Okay, so we will get this one. 5 multiplied by 1/5, or directly we can write it to make it simple, so you can write this one like directly. You can write this as a 1, it is -1, it is -3, 4, -2, -6, 3, -6, -50, and the augmented also 8, 19, 41. You can see it is only the pivot row change, because we only multiply the pivot row only with the reciprocal number of pivot entry. Okay, so we get this one. And then after that, our next task here to change all of the circle point of the pivot, because we have the pivot entry here. The next, we convert all the entry below the pivot entry to be 0. See this one, it has to be 0, so we will refer to this as a targeting these entries. As entry is changed to 0, it's called a target, so it's called a target. And it's called row as a target row, so we have to target row is a second row, and the third row is a target row, so we have to change the target row into 0. We always use the following to type 2 row operation, so we use the type 2 operation. What the type 2 operation say? In the type 2 operation say you have to see the target row. We can use a minus of target value, where target value refers to this one. Yeah, here's the target value, multiplied by the pivot row plus target row. The target row is the third one and the second one. So by using this one, we can take the next operation by multiplying this. Okay, we need more space, so we have to move left. Okay, we can take this one, for example, to 0 of the target 2.1, yeah, 2,1 and 3 and 2,1. We use the type 2 operation by using this one. Yeah, minus target row, we have the -4 times 1, 0, because we have the target value is 4, adding the minus operation, so -4 times pivot row. It is the pivot row is the first row plus target row. The target row is the second row, so that is for the type 2 operation, and we can have this one as okay. The number of that is -4. The result of this one is -4, 4, 12, and 30. Is minus absolutely. And the row, it is for the row 1. For the row 2, this one is 4, -2, and -6, and here is a 90. And then we adding this one for the summing. We have the new row 2, the new row 2. we have 0, 2, 6, and minus 13. Okay, the resulting is now substituted to place the old rule to producing. So we have the new row of the second row. But before we input this one to the matrix, we continue because we have two row here. The second row we have to change is the third row, but the third row is also use the same type. We have the type 2, so this one is a minus 3 multiplied by, so this is still the first row, so we can write is the first. We have the 3 column, then we will get the new row 3. You can write this here by minus the first column. So the first column you will get this minus 3, 3, 9, and minus 24. Then we have the result of the entries of the third one row. It is 3, minus 6, minus 15, 17, and 41. So we summing, then we have 0, it's minus 3, minus 8, and it is 17. It is the new row 3. So we have new row 3 here, and then we can input all of new row to the matrix. Now we have the new matrix. Okay, the new matrix will like this one. 1, it's been the minus 1, it is the minus 3, it is 8. The new second row, you can input it here. 0, 2, 6, and minus 13. And the third one, new row is 0, minus 3, minus 8, and 17. Okay, that is the new matrix. Or we can write this one as x and minus y minus 3z is equal to 8. And then 2y plus 6z equal to minus 13. And minus 3 minus 8 is equal to 17. Okay. We have the new system of linear equation here. Of course, this is simpler than before, but we will not finish yet because we don't have any satisfied number, the satisfied value of the y, z, or x. So our purpose here to get the satisfied value of those of each variables. And then we can continue to the next process. To the next step is we are looking for the new pivot because all the pivot has been, this one has been finished. It is finished. The first column and the first row finish. So we are looking, move to this one. What we can use, we can use the type 1 operation. Type 1 operation where we can multiply by the reciprocal of 2 and its mean. For the row 2 we can multiply it with null. Yeah. Then after you can multiply with null, we will have this new matrix. This one, 1, minus 1, minus 3, 8, 0, 1, 3, minus 13, second, and 0, minus 3, minus 8, and 17. Okay, that is the new matrix. After we multiply the second row to get a pivot element, to make it as a pivot element, and then continue, we have to change this one as a target value to be 0, and now we only have the target row only we have one target row, only one. So we can continue this process by using the type 2 operation. By using the type 2 operation, okay, we will change this row, this target value to be 0, so we can write in a third column. You can see the is, because it is the minus multiplied by minus, so we have the 3 and then multiplied by, because it is the pivot row is a second column, a second row, we can write here is second and then plus the third row, and it will be like this one, and multiplied by row 2. Yes, 0, 3, okay, 9, and this is the augmented, this is minus 39 second, and then the row 3, 0, minus 3, minus 8, and 17. And then summing this one, we have 0, 0, and this is a 1 and minus 5 second. Okay, and then it's look like coming to an end because we have only one variable here, and then we can write the variable like this one, or we can write first for the new matrix. Now we have the new matrix like this one, 1, minus 1, and minus 3, minus 9 second, and then here 1, 3, minus 31 second, and 1, and here 1 second. Okay, I'm sorry, this one is not this one. The sum of this one is 8. Then we can move to the system of linear equation like this. Or I think that 3z is minus is 8, and then y plus 3z minus 13 second, and then z is minus 5 second. Okay, so we obtained the value of z. After we obtain the value of z, of course we can get the other value of y, and of course the x value by using the substitution. By using the back substitution, we can get all of the value of each variable. So if we have the z value is minus 5, 2, we can write here y plus 3 minus 5 2 is equal to minus 13. So we will get the value of y is 1. Yeah, you can do this operation. The y is 1, and then after we get y is 1, we can get the value of z. The value of z we can get here x minus 1 minus 3 minus 5 second is 8. So we will get the value of z here is 3 second. Okay, is enough to get the value of variable by using the Gaussian elimination, and it's very complicated. You will, if you use the conventional elimination without using the Gaussian elimination, because we have the 3 variables. By using the Gaussian elimination, it will be easy, and the result of this one is 1, 3, 2, 1, and minus 3. So we have a unique solution here. Why is it a unique solution? Because it will be in a one point unique solution. So there is the x, y, and z. I hope you can understand it well, because it's not enough, and we will continue to other method for system of linear equation in the next video. Thank you.